So, I bet I'm not the only one enjoying the nature here in Helsinki. In comparison to other capitals in Europe, actually we are quite a unique one when it comes to nature. We have the sea, we have the forests starting just a few kilometers out of the busiest city center. But what do we really know about the forests and trees we have in our city and in our streets? What could we learn from them? Next up we have Professor Markus Holopainen from the University of Helsinki. He's an expert in laser scanning trees. Welcome, Markus.
Thank you, and good evening, everybody.
Yeah, so Markus, you're a professor of geoinformatics in the University of Helsinki. So can you explain a bit what do you do?
So I come from the Department of Forest Sciences, and my study line is there, forest resource management and geoinformatics. And my research group is also part of the Center of Excellence in Laser Scanning Research. And that's basically what I would like to talk and discuss today. And especially because we have had a lot of cooperation with City of Helsinki during last decade, actually 10 years. We have had several joint projects in which we have aimed to improve city tree registers and databases of city parks and forests. And actually in these projects we have developed methods that have been utilized also in operational forestry in Finland and actually also in some other countries too.
Yeah, so laser scanning, that I'm not so familiar with the method, and I bet that here are also some people who might not maybe have heard about it but don't know quite what it is. So can you explain a bit what is laser scanning?
Well, first of all, I would say that during the last 10 years, if you talk about natural resource management, this 3D remote sensing, especially laser scanning, is one of the main improvements. And by means of 3D data, 3D remote sensing data, we can get more accurate information from forest inventory and monitoring.
Yeah.
And okay, here we have that video. So laser scanner can be put, for example, to the airplane or helicopter. We call it airborne laser scanning. Laser scanning is so-called active remote sensing method. So that means that device submits short pulses, and the same pulses are recorded when they reflect back from the object. If we know exact location of the laser scanner, we can calculate distance from the object by using time. And in addition, we can get intensity of the pulses. And when we measure landscapes, it's possible to detect accurately ground and tree crowns. In addition, we can utilize also terrestrial laser scanning, here we can see it in this video. So if we measure from the field, we can get millions of the points for one forest. And actually, by means of this data, it's possible to measure individual trees very accurately, volume of the trees or biomass of the trees, and so on. And also we can utilize mobile laser scanning. So laser scanner can be put to mobile device like here. Actually, this is just for research purposes. This mobile device has been developed by National Land Surveying of Finland and our research group. But in the future, we aim to put laser scanners also, for example, to the harvesters. And actually the same methodology, the laser scanner is one of the main devices also in so-called robot or autonomous driving cars. So this technology is developing very fast.
Yeah, yeah. So what has laser scanning trees to do with sustainability then?
Well, sustainability. As I said, I come from my background is in forestry and forest sciences, and sustainability is always part of our research and also practical operational forestry. So economical, ecological, social points of sustainability are taken account. From my point of view, key issue is accurate forest information. More accurate information we have, better decisions can be made. And I have called our approach as 3D Precision Forestry. And in addition of development of technology, how to measure trees or forests more accurately, we try to make applications in which we can get added value from the new technology or more accurate information of the forests. For example, from economical point of view, we can utilize this, if we can go to the single tree level, as we can do in research purposes, but if we can go to the single tree level in operational forestry, we can optimize wood supply chain in forestry. And in the future, it's possible even increase degree of processing of wood products by using accurate forest information. In addition, we can measure and monitor forest health status or above ground biomass much more accurately than with traditional methods. So I would say that accurate forest information is a basis for sustainable use of forest resources or actually all natural resources.
Oh, so when I introduced you in, I was wondering what do we really know about the forests and trees we have here in Helsinki, and I know that I bet you are the right person to ask. So what kind of projects you have done here in Helsinki? What have you discovered?
Actually, we started already 10 years ago, or over 10 years ago, when we had drought damages. So we had very dry summers. I think it was 2003 or something like that. It's it's 15 years ago, actually, already. Time flies. But anyway, that time we inventoried those damages, and by means of aerial photographs, actually, and field measurements. That time we didn't use laser scanning yet. But lately, if we talk about the last 5 years, we have used laser scanning. First, airborne laser scanning, and lately also terrestrial laser scanning for measuring city trees. And we started from tree register. City of Helsinki has tree register of road trees, and there are about 20,000 trees, and we developed airborne laser scanning based method for mapping of those trees and measuring those trees automatically. And I would say that this was the first time, even globally, when a single tree level airborne laser scanning method was used operationally. That was some 5 years ago. During last 2-3 years, we have utilized the same method in city parks. So our aim is to map park trees. And we have we have calculated by means of airborne laser scanning that we have some 350,000 park trees in City of Helsinki. And what to do with this data? City of Helsinki is utilizing this 3D information or this tree level information of our road trees or parks for management of those areas and trees. And actually this is, I would say that City of Helsinki has been some kind of testing laboratory, especially when we are developing this single tree level methods for operational level, because in the future we aim to utilize the same methods also in other areas. I mean in for example, in private forests operationally.
Yeah, so you have been doing quite a lot of collaboration with the City of Helsinki, I guess. Yeah.
Yes, we have had, as I said, over, well, let's say already 15 years. And actually, first of all, it was because City of Helsinki has very good databases and materials, remote sensing materials. And we utilized the materials in our research. That time, that material was not open for all. But it was possible to utilize those in our research and teaching. That was the first step. But lately we have had also joint research projects, and I have had some doctoral students, and actually at least one PhD or doctoral thesis has just finished from these issues in the City of Helsinki.
Yeah.
And several master theses also.
Yeah, and you're part of the Helsinki 3D city model project also.
Yes, actually this, we are dealing with the parks and road trees, but the City of Helsinki, they have also this 3D city model project, so for built areas, so our project is part of that. So we are dealing with the trees, but the City of Helsinki, they have made a 3D model for whole city. And actually, do we have?
Yeah, we can see a video of it here.
Actually, yeah. And actually, the remote sensing material that they have utilized is the same that we have used. So airborne laser scanning and aerial photographs. And by means of those, it's possible to make 3D model of the. So they are dealing especially with buildings, and actually they have the same idea or same vision than we have had in forests, that it's possible to have added value or different kinds of applications by using this 3D model, if he compared to the traditional 2D maps that we have had in the City of Helsinki. And one possible application is air quality monitoring that will be discussed next by Mona Kurppa.
Yeah. So actually we can now switch and we can get Mona on the stage. But thank you so much, Markus, for coming up today.
Thank you.